we have definite integral. So when we have definite integral, first step, what we have to do? We have to check if our function is continuous. So we need to check the domain of our function first, because we have here in the denominator 1 plus r, we cannot have 0 in the numerator, so r must be different than -1. Next, because we need to do integration by parts, let me remind you formula. When we have definite integral from a to b of f of r, because in this case we have integral with respect to r, times g prime of r dr, this is equal f of r times g of r, and next we have to put vertical bar. On the top we have upper limit b, and on the bottom we have lower limit a, minus, and we have definite integral from a to b of f prime of r times g of r with respect to r. Function f and g prime must be continuous. So first let me rewrite this expression to multiplication, because we need to have multiplication to use this formula. We have definite integral from 0 to 2, and we can rewrite this, that this is equal r times e to power r, and we will take this whole expression in parentheses to numerator, so it will be times 1 plus r to power, we need to put negative sign before 2, and we have integral with respect to r. We have r times er, this is continuous function, and our function 1 plus r to power -2 is continuous without r equals -1. Only for r equals -1 our function is discontinuous. But we have here interval from 0 to 2, so everything is okay, because -1 is not included. So now let me put that our f of r function is equal r e to power r. So next step, we need to find f prime of r. We need to have product rule to find derivative of this expression. So first we need to find derivative of r is 1 times e to power r plus, and next we have to copy first expression times derivative of e to power r is e to power r. What we can do here, we can factorize e to power r, so we will have f prime of r is equal e to power r, and in parentheses we will have 1 plus r. We have f prime. Now whatever left is our g prime. So this is equal 1 plus r to power -2. So we need to find antiderivative. So g of r is equal negative, and in parentheses we have 1 plus r to power -1. You can always check if you take derivative of this expression, you will get this. So next we can just substitute to our formula. This is equal, we have f of r times g of r, so we have r times e to power r times, and in brackets we will put negative 1 plus r in parentheses to -1 power, and we need to put vertical bar. On the top we have 2, and on the bottom we have 0, because we have definite integral from 0 to 2, minus, and we have to rewrite integral symbol from 0 to 2. F prime is equal e to power r times 1 plus r times g is equal, we'll put in brackets this because we have negative sign, and 1 plus r to power negative 1 with respect to r. So this is equal. First we will simplify it a little. So we have here positive times negative, so will be negative, and we have r times e to power r, and in parentheses we will have 1 plus r to power negative 1, and we have limits from 0 to 2 minus, and because we have negative and negative, so we have to change the sign to positive. We have integral from 0 to 2 e to power r times, and we have this minus we don't have now, we change this to plus. So now we have the same base. When we have the same base, we have to add exponent. Here we have invisible 1. So 1 plus negative 1 is 0. So we have 1 plus r to power 0 with respect to r. This is equal. Let me rewrite first expression. We have negative r e to power r. And because we have negative exponent 1 here, we can put this expression in parentheses to denominator. To first power we don't need to write. We have limits from 0 to 2 plus, and now when we take to power 0, 1 plus r, it will be 1. So we have integral from 0 to 2 of e to power r only with respect to r. So this is equal. We will have to copy one more time first expression. Limits from 0 to 2, and we have plus. We have integral of e to power r is e to power r, and we have vertical bar, limits on the top 2, on the bottom 0, be negative sign. We have to plug first upper limit. We have to substitute r's by 2. So we have negative will be 2 times e to power 2 over 1 plus 2. And we need to subtract the lower limit, so we have minus, and we will put this in brackets because we have negative sign. So we have negative, and now we substitute r's by 0. So we have 0 times e to power 0 over 1 plus 0 plus, and now we need to substitute first upper limit for r. So we have e to power 2 minus lower limit is 0. So we have e to power 0. This is equal. We will have negative 2 times e to power 2 over 3. This expression will be 0 because 0 times whatever we have here will be 0. So now we have to put plus e to power 2, and we have minus e to power 0 is 1. So this is equal. We can factorize e to power 2. In parentheses we will have negative 2/3 plus 1, and we have negative 1. So this is equal e to power 2 times negative 2/3 plus 1 will be 1/3. So we can put in front 1/3 e to second power minus 1. Now you can use calculator and find this value. We have 1 over 3 times e to second power minus 1. So this is equal 1.46. This is my solution.